order to find Kp, you need to make the fraction. In all of the products of the reaction go in the numerator, and all of the reactants go in the denominator. So for this equation, NOBr is the product, so it goes on top. The coefficients from the reaction become the exponents for the reactants. So in order to find delta N, you take the sum of the coefficients of the products and then subtract off the sum of the coefficients of the reactants. So for this problem, the sum of the products is 2 and the sum of the reactants is 3. So delta N equals 2 minus 3, which equals -1. And you do the same process for this. So 2 minus 4 equals -2. So in order to find Kp at this temperature, you use the equation Kp equals Kc times RT to the exponent delta N. Kc for this reaction is 0.45, as stated in the question. R is 0.0821 liters ATM per moles Kelvin. That is a constant. The T for this equation is 650 degrees Celsius plus 273, which makes it 923 Kelvin. And delta N equals -1, which was figured out in question number 2. When you plug in the numbers, the answer turns out to be 0.00594. At this temperature, you do the same thing. You go through Kp equals Kc RT delta to the delta N. And after you go through it all, you get Kc equaling 0.410. So, in order to find the proper relationship for number 3, the correct answer is A. When you cross cancel the same elements on both sides, you get reaction 3. So you add the two reactions together and get rid of the same things on both sides. To find the equilibrium constant for K1 and K2, you make the fraction that we made in the first problem, with the products going on top and the reactants on the bottom. So you do the exact same thing for K3, reactants on the bottom, products on the top. And the coefficients are used as the exponents. So, in order to find the total K value, you need to multiply the K values for the individual reactions, so C is the correct answer. So in order to find the constant for K, you multiply the answers you got. So 3.92 times 3.3 times 10 to the 4th. So your K for reaction 3 is 1.29 times 10 to the 5th. Now for the skills practice, you use the original equation Kp equals, oh no you don't, you use the equilibrium constant, which is products over reactants, and then you plug it into the equation and solve, so you get an answer of 2.31 times 10 to the -4th. And you use that equation in order to get 0.0261. And Kp at this temperature, you use the exact same equation that we've used, plug in all the numbers that you know, and you get 0.026. For the concentrations, you just plug them into the equations. For Kp, you use the equation we've used for everything else, and you get Kp equaling 1.14 times 10 to the 6th. And now you're done.